A recursively defined sequence is a sequence where you must be given one or more of the first few terms. And all of the following terms after that rely on the previous terms right before it. So let's look at an example. This is a well-known sequence called the Fibonacci sequence, where it gives me the first term, u sub 0 is 1, and u sub 1 is 1, where the rule is u sub n minus 1 plus u sub n minus 2. Okay, so what that means is u sub n minus 1 is the term right before that term you're finding, and u sub n minus 2 is the term two terms before the one you're finding. So if the first term is 1 and the second term is 1, then to get the next term, you add the term right before it plus the term two terms before it. So 1 plus 1 is 2. And now to get the next term, you add the term right before it, which is 2, plus 2 before it, which is 1. So the next term in the sequence would be 3. And then the next term would be 2 plus 3, so it would be 5. The next term would be 5 plus 3, so it would be 8. And then 5 plus 8 is 13, and so on. So that is known as the Fibonacci sequence, where it is recursively defined, which means you get the next term by using the previous terms and the rule. Okay, so we can set up a recursively defined sequence on our calculator. So let's go look in our calculator. Remember, I want to be in sequence mode, and if I go to y equals, then I can leave my minimum as 1, which means I want to start with the first term, and then I'm going to put in the rule for the recursively defined sequence. So it's going to be u of n minus 1, which is the term right before it, and the u is the second function on the 7. The little blue u is the second function on the 7. Plus, and the n is the variable, remember, second 7 u of n minus 2. So remember, u of n minus 1 means u sub n minus 1. So it's a subscript, but that's the way your calculator does it. So we're telling the calculator what the rule is. Then it asks for the first term, which was 1, and the second term, which was 1. And now we can look at the table. If I look at the table, it gives me the Fibonacci sequence. It gives me the sequence and all the terms. And if I want to know what is the 12th term, I can just scroll down and see that the 12th term is 144. So let's do one more example of a Fibonacci sequence, where we want the first 6 terms of this recursively defined rule. Then find the 15th term. Okay, so we can do it by hand, and then we can do it on our calculator. So the first term is 2, the second term is negative 3. And the rule says 2u sub n minus 2 plus u sub n minus 1. So remember, u sub n minus 1 is the term right before it, the one we're finding, and u sub n minus 2 is 2 before the one we're finding. So I'm going to do 2 times 2 plus negative 3, which is 1. So the next term in the sequence is 1. And the next one, we're going to do 2 times negative 3 plus 1. 2 times 2 before it plus the 1 right before it. So that would be negative 6 plus 1, which is negative 5. Okay, let's do a couple more. And the next term would be 2 times 1 plus negative 5, which would be negative 3. So 2 times 2 before it plus the 1 right before it. That's what the rule is telling me. So let's see. I can do a couple more. So the next one would be 2 times negative 5 plus negative 3, which would be negative 10 plus negative 3, which is negative 13. And we can also use our calculator to find the 15th term. So let's go to our calculator. We're going to go to y equals. Let's clear this. And we're going to do 2 times u of n minus 2. And then plus, second, 7 for u of U of means U sub, remember, n minus 1, like that, where the first term was 2 and the second term was negative 3. So now we have this recursively defined sequence in our y equals. We can go to the table and we can see what the 15th term was. 15th term is negative 5,459. Okay, so that's how we do recursively defined sequence.